Hello and welcome to AI for Developers. I'm AI Educator Talking Bot. Today's lesson is titled Why I Rewrote My Trading Engine in Rust. Latency, Safety and Concurrency. Our initial trading engine, while rapidly prototyped in Python, hit a critical performance wall. Global interpreter lock. GIL. Contention crippled multi-threading, impacting latency-sensitive operations. We observed unacceptable slippage during peak trading hours due to increased order execution times. Sharp ratio degraded measurably due to these inefficiencies. Rust offered a compelling alternative: memory safety without garbage collection, fine-grained control over hardware resources, and fearless concurrency. The ownership and borrowing system guarantees deterministic behavior, crucial for high-frequency trading systems where predictable execution is paramount. This eliminates a class of bugs that plague other languages. Our Rust implementation focused on zero-copy data structures, minimized allocations in the hot path, and direct memory manipulation. We leverage stack-based and arena-based data structures wherever possible, reducing garbage collection overhead. Profiling with tools like perf and flamagraphs became crucial for identifying and eliminating performance bottlenecks. Rust's async await enabled the creation of highly concurrent agentic loops. Each agent handles specific trading tasks, e.g., market data ingestion, order placement, risk management, independently and concurrently. This architecture significantly reduced latency and improved responsiveness during high-volume events. We used channels for inter-agent communication. Rust's robust error handling mechanisms prevented unexpected crashes. We implemented panic recovery strategies to gracefully handle exceptional situations and maintain system stability. Extensive unit and integration tests, including property-based testing, were used to ensure correctness and resilience. We integrated a private retrieval augmented generation (RAG) system, powered by a Rust-based inference engine, to provide real-time market insights and adaptive model retraining. This system analyzes news feeds, social media sentiment, and order book data to identify potential trading opportunities and adjust parameters on the fly. The RAG system can also analyze historical trade data to identify areas for engine optimization. Our Rust trading engine is deployed on a distributed cluster of bare metal servers located in close proximity to major exchange data centers. We employ containerization and orchestration technologies, e.g., Docker, Kubernetes, for efficient deployment and scaling. Continuous integration and continuous deployment, CI/CD. Pipelines ensure rapid iteration and deployment of new features and bug fixes. Hardware acceleration, such as FPGAs, is being explored for ultra-low latency components. Our transition to Rust is a key component of our Quant AI system v6. By 2026, the complexity of DeFi and traditional markets demands robust and scalable engines. We're actively researching zero-knowledge proofs in Rust for enhanced security and privacy in our trading strategies. Furthermore, integrating the engine with decentralized Oracle networks enhances data integrity and resilience against manipulation. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.